Welcome students. So in this session we will discuss about the 8051 interrupts, that is what are the types of interrupts, what are the registers which is accommodating with that interrupts. So that is the topic which we are going to discuss today. In this interrupt is nothing but generally if we get any disturbances while executing the main program, so that is called as the interrupt. Here in some technical way we are going to see that what does the disturbance means. Okay, so it is nothing but an event which will stop your program, which will suspend your main program execution for a some time period, that is temporarily. Okay, so interrupt is nothing but the event that temporarily suspend the main program. Okay, and here there are many there are 5 types of interrupts which we have discussed, which we are going to discuss over here. So each and every type will taken as a bits. Okay, so it consists of 5 types. One is external interrupt 0 and timer overflow bit for 0, timer 0. We have discussed all these things already. Timer overflow bit, we used to say that as TF bit, so which is nothing but TF0, and external interrupt for timer 1 and timer overflow for timer 1, as well as serial port events. We have seen the receive interrupt and transmit interrupt in the serial port, right? So that is nothing but serial port events, RI and TI flag. Okay, so we are going to discuss again these 5 bits in the in terms of registers which is accommodated with that interrupt registers. Okay, so we have 2 types of interrupt registers over here. One is interrupt enable register, which is represented as IE, and the other one is interrupt priority register, which will be represented as IP. Okay, to discuss about these 2 registers, we will see first the interrupt enable register. It consists of 8 bits from D0 to D7. Okay, so we will discuss what is that from D7th bit. This D7th bit is nothing but EA pin. EA is nothing but initially all the interrupts will be in disabled condition. Okay, so once if you reset your controller, then automatically all the interrupts will be in disabled condition. If you want to enable that interrupt or if you want to acknowledge any interrupt, you have to consider the pin EA. Okay, if this pin EA is equal to 0, then it shows that your interrupt has not been acknowledged. If this interrupt if that pin EA is equal to 1, it shows that your interrupt has been enabled individually. So one by one your interrupt program will be here. So if this EA is equal to 1, your interrupt will be enabled. If this EA is equal to 0, your interrupt will not be acknowledged. It will not be enabled. So initially, what is the condition of your interrupt during after resetting your microcontroller? It will be in the disabling mode. Okay, and bit number 6 and bit number 5 is reserved for the future purposes, and bit number 4 is nothing but serial port interrupt. Bit number 4 is nothing but the serial port interrupt pin. This pin will either enable or disable. If this bit is equal to 1, it will enable the serial port interrupt. If this bit is equal to 0, it will disable the serial port interrupt. Then you are going to look for ET1 and ET0. These 2 pins, we will take these 2 pins, ET1 and ET0 over here. So these 2 are timer bits, timer interrupt bits. So if this timer overflow occurs in timer 1, that is timer overflow interrupt occurs in timer 1, then ET1 bit gets activated. Okay, if overflow interrupt occurs in timer 0, then ET0 bits get activated. Okay, so these 2 bits, bit number 3 and bit number 1 is for timer bits. If the timer overflow interrupt occurs in timer 1, the bit 3 will be activated. If the overflow interrupt occurs in timer 0, then bit 1 will be activated. So these 2 are for timer 0 and timer 1. And next, coming to this EX1 and EX0. EX1, EX0 in the sense this is for EX0 is for timer 0 and EX1 is for timer 1. Okay, so this EX is nothing but So this is for external interrupt 0, this is for external interrupt timer 1. Okay, this will enable, this EX0 and EX1 will enable or disable the external interrupt at timer 0, and EX1 will enable or disable the external interrupt at timer 1. Okay, for example, if you are taking this case EX0 is equal to 1, then at timer 0 your external interrupt has been enabled. If this is 0, then at timer 0 your external interrupt has been disabled. Okay, likewise if you are taking the condition EX1 equal to 1, so for timer 1 your external interrupt has been enabled. If this condition is 0, then for timer 0 your condition has been disabled, your external interrupt has been disabled. Okay, so this is the condition of these two terms EX not. Okay, so if this is for the case ET1 ET not, overflow interrupts. Okay, so if this overflow interrupt occurs in timer 1, then ET1 will be enabled, and for timer 0 this ET not will be enabled. So this is all about your interrupt enabling register. Okay, what all the registers what all the bits we have seen over here? Initially you have to enable the interrupt initially. So for that, while you are giving the reset condition to your microcontroller, automatically it will be in disabling state, right? So while you are enabling the interrupt, you have to consider this EA condition. If this condition is equal to 0, then no interrupt will be acknowledged over here. If this EA is equal to 1, then automatically it will be enabled individually. Okay, so these two are for the future use, and ES is nothing but in order to enable or disable the serial port. ET naught is for the overflow interrupts which occurs in timer 1 and timer 0. EX1 and EX naught is nothing but enabling or disabling the external interrupts for timer 1 and timer 0 respectively. Okay, so next coming to the interrupt priority register. Interrupt priority register in the sense when we are going to activate this register. In case, for example, if you are if you are executing one type of program, one main program, but you are getting some 2 to 3 programs at a time. If for the while you are executing this main program, so how can you choose which program has to be executed first? After suspension of this main program temporarily, which program has to be executed first? So that has to be prioritized. As per the priority which we are giving to that program, that will be executed first, right? So that is nothing but the interrupt priority register. Clear? Generally it consists of 8 bits of register. It starts from D0 to bit number D7. Okay, it is represented as bit 1 to bit 7 over here. So generally we have to take it as 8 bits over here. Okay, so bit number 7 and 6 is reserved for the future use. So there is no use of these 2 bits, and this bit PT2 is used for the timer 2. Okay, this is the priority bit, that is interrupt priority bit, which is allocated for timer 2, where in this 8051 microcontroller we are not using the timer 2 over here. So it is applicable only for 8052 microcontroller. So this is not applicable in this 8051 microcontroller now. So when you are coming to this PS is nothing but the interrupt priority in the serial port. Okay, so when you are going for the serial port, there the interrupt priority will be represented by using this bit, PS bit, that is bit number 4. Clear? Next, coming to the bit number 3, it is for, here we will discuss with bit number 3 and 2. We will consider these 2 bits for bit number 3 and bit number 1, sorry, okay, bit number 3 and bit number 1, which is nothing but PT1 and PT0. PT is nothing but the interrupt priority bit. So each and every timer consists of its own interrupt priority bit. Clear? So PT1 is for interrupt priority bit for timer 1, and PT0, this is the interrupt priority bit for timer 0. So PT1 and PT0 will give you the interrupt priority bit for timer 1 and interrupt priority bit for timer 0. Okay. Next, coming to PX1 and PX0, we will take these 2 bits. Okay, that is these 2 bits. Okay, so this is PX0, PX1 is nothing but the external interrupt pin. So external interrupt priority for timer 1 and external interrupt priority for timer 0 bit. Okay, so this is given over here. So IP7, that is bit number 7 and 6 reserved for that, and bit number 5 is for, it is only applicable for 8052 microcontroller. It is not applicable for 8051 since we are not using timer 2 over here. And bit number 4 and yes, bit number 4 is for serial port interrupt priority bit, and bit number 3 and 1 is for timer 1 interrupt priority bit and timer 0 interrupt priority bit, and bit number 2 and 0 is for external interrupt 1 priority bit, and 0 is for external interrupt 0 priority bit. Okay, so as per the priority, your bits will be enabled over here. So as per that, the programmer can execute the program, interrupted program over there. Okay, so now coming to the program, here we can understand how when your interrupt programming occurs, when the main program is executing over there, so how your program counter moves on to the interrupt program. So that's what we are going to see. See, the sum multiplication program we are executing over here. During the process, interrupt program occurs. So at that time, what will happen? Your programmer, that is your processor, stops the current execution of the main program, current processing of the main program, and it changes the program counter changes its address to the location where your interrupt has been stored. Your interrupt program has been stored. Okay, that is represented in ISR, that is interrupt service routine. This is called as interrupt service routine. Okay, so your program counter will be moved to the location where your interrupt program has been stored. So in that, your R7, that is the contents of R7 has to be moved later, and if there is no 0, jump if not 0. If there is no 0, it will be returned to the main program. That is, it will be stored in the 6th pin of your port 1 and it will be moved to the main program. If there is 0, it has to be checking, increment and checking. Continuously it will be move on over here. So once it gets returned, after that, after completion of this entire interrupt program, your program counter will move on to the main program for execution, and again it will start its execution at the stage where it left the main program. Okay, so this is the method where it will start the interrupt and how it will stop the interrupt and again move on to the main program. Clear? Then coming to the difference between your C and embedded C, generally you have studied the C programming, right? So the same thing is applicable for your embedded C programming also. Generally the difference is here it was development in nature, but in embedded C it possesses the cross development in nature. While you are programming while you are programming in C language, it does not depend on any hardware architecture, right? But when we are comparing with that, when you are using that in the embedded programming, we have to consider the hardwares which we are using over there, and along with that we have to do the programming. So here we are using microcontrollers, right? So we are supposed to consider the microcontroller pins, its registers, how its register values, and its addressing modes, its instruction sets, everything while we are programming in the C. That is the difference between your normal C programming language and the embedded C programming language. And here we are using the C programming for some desktop applications, OS and PC memories over here. And in this embedded C, it is used for resources like RAM, ROM, input-output peripherals, and whatever we are using in this embedded controller device. For all those things, we have to use this embedded programming like RAM, ROM, and input-output peripheral devices. Okay, so in this embedded system, why we are preferring this C code and other comparing with other languages. Why we are preferring the C code in the sense, it is very easy to understand, it has high reliability, and it is highly portable, and the scalability is also high when you are comparing with that other code languages. Okay. And then coming to the addressing modes of your microcontroller, 8051 microcontroller, we have discussed all these addressing modes you have been discussed with the previous semester itself. So it consists of register addressing mode. These are all the commands how we can use when the programmer is programming using the embedded C language. Okay. So when you are taking this move A, R2, R2 is nothing but the register where your memory location will be present. At that memory location your data will present. Understood? That is, this is the register addressing mode. Sorry, in this register your data will be present. Okay, register addressing mode in the sense, in this register R2 your data will present. So that data has to be moved to this accumulator. And if it is immediate addressing mode, your data will be given directly to the command. So hash 20H is nothing but the data which has to be moved to the accumulator. Okay. While you are coming to the direct addressing mode, here this 30H is nothing but the address where your data is present. So from this address you have to fetch the data to accumulator. So that is called as direct addressing mode. Okay. Indirect addressing mode in the sense, this R0 register where your address of the data will be present. So in this R0, it contains only the address, for example 40H or 50H, like that of address will be present. From that address you have to take the data which is present over there. So for example, if you have 25, so this data 25 has to be moved to the accumulator, not R0. Understood? That is the meaning of indirect addressing mode. What is the meaning of indirect addressing mode? Your register will be given, but in that register also you will not have the data. It contains only the address of that particular data. Okay. So for example, your R0 consists of 40H, 50H or 60H, something like that. It will contain only the address. In this address only you will have the data which you have specified. So you are not supposed to move this address to this accumulator. You are supposed to move this data accumulator. Understood? So this is called as indirect addressing mode. External indirect in the sense, generally in order to represent the external transfer between the transfer between the accumulator and the external device, external memory device, we will use the command called DPTR, that is data pointer register. Through this register only we will use this external memory command, right? So this external indirect in the sense, it will move from this data pointer register, the data will be moved to the accumulator. In order to specify the external memory and accumulator transmission, what we are doing, we are going to represent with move X over here. Okay, so this is called as external indirect. Indexed in the sense, your DTPR register will be, the data pointer register will be added with the accumulator content and it will be moved on to the accumulator. Okay, and implied register, it will be given as the command RLA. So these are all nothing but the addressing modes which is specified in this 8051 microcontroller. Clear? Next, coming to the assembler directives. Assembler directives in the sense, generally whenever you are starting the command of whenever you are starting the program of 8051 microcontroller, you have to start with origin, that is ORG. For example, you have to start with ORG 0000H. So this will represent you that your program has to, your program is going to start. So origin, that is ORG 4 zeros of H. So this will give you the beginning of the address. Okay. The next one is nothing but EQU. This is the command when you will apply, whenever you have to give the content some constant value without displaying any equations, without displaying any command. So at that time you have to give this EQU command. So there will not be any specific memory location, or else there will not be any specification of address, and there won't be any specification of register. So it will be given directly, so it has to be taken as EQU directly over there. So this command is for that. And END is nothing but completing your program. You have to give it as END in order to stop your program. That is in order to stop the main program or source file over here. Okay, so these are all the assembler directives which is constant, which has to be constant for your 8051 programming. Clear? These are all the instruction sets. Instruction sets in the sense, generally we have data transfer instructions, arithmetic instructions, logical instructions, branch instructions and bit level instructions. Data transfer instructions in the sense, whenever some data has been transferred from any between registers or from register to accumulator or from accumulator to some other registers, that will be taken as the data transfer instructions over here. That's what we are taking this from. This content from register R2 has been moved to accumulator A, so that has been taken as data transfer instructions. And next, going to the arithmetic instructions, if you want to add any data or if you want to multiply, division, so all these data will be taken from this 20H is nothing but direct data. So that data have to be added with the contents of accumulator and it will be stored in accumulator. Okay, it is not, see, we can give this command as add AB also, so that the content of B register and content of A register will be added and that will be stored in A. Again it will be stored in accumulator, but here what we are doing, we are directly giving the command, we are directly giving the data. This 20H is nothing but data, it is given to A, like the content of accumulator will be added with this 20H and it will be moved to the, again stored in the accumulator. So that is nothing but arithmetic instructions. Okay, logical instructions in the sense, you have performed with OR gate and NAND operation, NOR operation, NOT operation, HEXOR operation, everything, right? All these things can be performed by using this logical instructions. Clear? And logic A, 30H in the sense, this 30H is nothing but the address where your data is specified. So that data and the content of this accumulator register have to be AND operated in the sense, for example, if this 30H consists of 1, the data 1, and this accumulator consists of data 1, these two has to be ANDed. What is the operation of AND over here? For if you are giving two inputs of AND, what will be the output? So 1 is the output. This 1 has to be stored again in this accumulator. So that is the command, that is the entire meaning of that command. AN instructions, all branch instructions like a jump if not 0, jump if 0, jump if carry, jump if not carry. So everything comes under your branch instructions. It will be represented as, here we have represented as jump, right? So if it is jump if not 0, then it will be represented as JNZ. If it is represented as JZ, that is jump if 0. If it is jump carry, JC. Okay, so while you are doing arithmetic operations, like if you are doing any addition operation, then there is a possibility to get carry, right? So that will be stored, that is called as jump carry. If carry is not present, that is jump if not carry. So all these instructions will come under the branch instructions over here. Okay, next one is, the last one is bit level instructions. So if any bits want to set or reset, so that will be comes under the set B underscore bit. For example, we have, if you want to start the timer, okay, if you want to start the timer, what is the command to start the timer? Set B, what type of timer you want to set, either timer 1 or timer 0. It prefers to the user, right? I want to start the timer 0. So what is that bit in order to start the timer? TR0 bit should be 1, right? So if you are giving the instruction set B TR0, automatically your timer 0 gets activated. So that will be given by this bit level instruction. Clear? So set B, that bit corresponds to TR1 or TR0 or TF0, TF1, everything. So all these bits can be enabled by using this bit level instructions. Enabling or disabling occurs over there. Okay. So totally that's all about your entire topics which we have covered with this 8051 microcontroller. So far this is the topic so far what we have discussed along in all the sessions. Like we have come across with the pins and signals of 8051, where you will have 40 pins of microcontroller, and we have discussed what are all the functions of those pins which is allocated over here, and how many ports are present over there. There are 4 ports are present over there. Each and every ports have its own latches in order to act either in input or output. Initially these ports will be in output mode, and we have to set, if you want to act it in the input mode, it has to be written into, that is the latch has to be written as 1. In that latch we have to write 1 in order to set the input mode. Okay, so all these configurations we have discussed with pins and signals, and IO ports we have discussed the port 0 configuration, port 1, port 2 and port 3 configuration, how these configurations are getting work along with it. So all these things we have discussed in this IO ports. And coming to the CPU registers, we have discussed about nearly 6 types of registers, and what are all the bits accommodated in those registers, and how these bits can be activated and come across in that CPU registers, right? And this memory organization, we have discussed about 2 types of memory: program memory, data memory. So in this program memory, what kind of allocations are there? Like ROM allocations of 4 kilobytes of ROM we are using over that as an internal ROM, and RAM is 128 bytes of internal RAM is using as a data memory, and 4 kilobytes of internal ROM is used as a program memory. So everything we have come across with the memory organization, right? So in the serial communication we have discussed what is the meaning of serial communication, what are the types of serial communication, what are the protocols which is coming along with that. So mainly we have discussed about the UART protocol in that serial communication, why we are not going to the parallel communication, what are the disadvantages of parallel communication, everything we have come across with that serial communication topic, right? And the next one is 8051 interrupts. We have discussed with the types of interrupts and how these interrupts can be enabled, and how these enabled interrupts can be prioritized while you are programming. So everything we have come across with that 51 interrupts. And one more section I have left over, which we have discussed with the timer bar counter. We have seen the timer bar counter logic also. We have seen about the 2 types of timers, which is T0 and T1 over here. If this, and what are all the registers which is accommodated with that timer bar counter register, and how how the same registers are acting as both timer as well as counter. That is, if the C bar T dash pin is equal to 1, it will act as a counter. If this bit is 0, it will act as a timer. Okay, so these are all the things which we have come across. The timer means it is used to generate the time delay, and if it is the counter, it will count the events which is happening outside the microcontroller one by one. So these are all the topics, and in whatever mode it is getting activated, like mode 0, mode 1, mode 2. We have discussed about the 4 modes in the timer bar counter logic. So all these things we have come across with and along with some programs also we have come across with all these concepts in the 8051 microcontroller. So finally we will go on with one quiz. I have given you some questions, like I have given you 3 questions. Just note down the questions and try to get the answers for these questions in the upcoming session. You just provide the answer in the upcoming session. Okay, just note down the questions. Over. So kindly find out the answers for that session, for the given questions. Go through all the concepts which we have come across with. Thank you.